All right, so today we have angles formed by chords, secants, and tangents. Okay, a secant line is a line that intersects a circle at 2 points. A chord is a line segment with endpoints on the circle. Okay, endpoints on the circle. That's the important part for this one right here. Endpoints on the circle. Okay, so the next part, it says a tangent line intersects a circle at only 1 point. So it basically only touches it at a single dot, one single point. So let's take a look at right here. We have a formula for my angles. We have a formula for my angles here. So this is going to go along with what we have here. The measure of an angle formed by two chords that intersect inside a circle is half the sum of the measures of the intercepting arcs. Now, I'm going to use my colored pencils and I'm going to identify the pieces that I have. And for some reason, someone actually took my box of colored pencils. I know, I was yelling at you guys saying, like, get your crap together, and then all of a sudden, I'm looking, I'm like, my box is missing. I know, that's what I get. No. Oh, no. Alright. Alright, anyway. Okay, here we go. Okay, so a couple things. AB. So this is going to be my arc, AB. So it's this piece, whatever the value that I get for here, and CD is going to be this arc over here also. And that would give me this angle right here. Now, serious question. Since this makes an X, this makes an X right here, right? So this one, if the angle is on this side, would it change anything? If the angle's on this side right here, would it change anything? No, why? Vertical, very good. Now, these are vertical angles here. So if it's on this side or this side, it would be the same. Okay, so now, first, we're going to do the example. So I'm going to talk about my pieces. So now I know that I'm going to have a minor arc right here. I'm going to have my other minor arc is over here, right? So my formula, which I'm going to look at right here, so measure angle X is equal to 1/2 parentheses. What are my two values?
90.
Okay, 90 and 50. So it's going to be 50 plus 90, right? Yeah? Okay. So there we go. So we have that right there. So 50 plus 90 gives me 140. What is half of 140?
70.
70. Very good. So measure angle X is 70 degrees. You can't see what?
Maybe you see too far.
You can't see? What can't you see?
The numbers.
Oh, the numbers? Should I try to make them a little bit bigger? Okay, I didn't know if I'm using the wrong color or something, or... Alright, so let's take a look at this one over here. So, I'm going to mark my pieces. So, I'm going to have, let's see, right here. And right here. So, my formula here, measure angle X is 1/2 parentheses 70 plus 125. So, please do that. If you need to use your calculator, you can. All right. What'd you get?
97.5.
37.5?
97.
97.5?
Yeah.
At least it's not 98.3.
97.5 degrees?
Yeah.
So, how did we get 97?
Because you added 125 and 70, which equals 490, and then you divide that by 2.
Very good. Very good. All right. I will slow down that a little bit. 70. Actually, I'm just going to do the whole calculator part. So I'm going to go start with my 1/2
125 plus 70.
parentheses.
Mister,
Huh?
125 plus 70 is not 190. I mean, not 190. It's 195.
Yeah, it's 195 divided by 2 though, right?
That's what we said.
Yeah, oh, I thought you said 190, that's why.
Oh, no. Yeah, so right here for the calculator, I did the whole thing in the calculator right there.
Okay,
So it's 97.5?
Okay, I thought you said 190, that's why.
Oh, okay. All right, so let's take a look at this other one. Now, this other one, it gives me the angle on the inside. So that's slightly different, isn't it? So this number in my formula would go out here, wouldn't it? Okay, so let's go ahead and try and do that. So I'm going to say that 73 is equal to 1/2. So I have my two values. So I have here and I have here. So I have my two values there. So 1/2, open parentheses, x plus 96. Now it turns into an algebra problem. So there's a 1/2 out in front of my variable, right? Say yes.
Yeah.
Now, how do I undo the 1/2? I don't want it over here on this side. I want to get rid of it.
Multiply by 2.
Multiply both sides of the equation by 2. Very good. So multiply both sides of the equation right here by 2. So once I do that, so I'm going to multiply by 2. So over here on this side, I should get 146 is equal to, what's going to happen to that 1/2?
It's gone.
It's gone. It goes away. So I'm left with,
X plus 96.
very good, x plus 96. Now, what am I going to do? I'm trying to get the x by itself. So what would I do to get rid of the 96?
Subtract 96.
Very good. Subtract 96.
Equals 50.
So I should get how much?
50.
50 equals x. So x is 50 degrees. Not too bad, right? No? Okay, good. All right, so now the next thing is we're going to start talking about some that are on the outside. This ones right here are on the inside. Now we're going to talk about angles that are on the outside. It says the measured angle formed by two secants that intersect outside a circle is half the difference of the measure of the intercepted arcs. Now, a lot of big words. I'm going to break it down into smaller words. Smaller words. My arcs. So now, see this angle out here?
Yes, sir.
Okay, this one right here is two secants. So I'm going to write on top of that two secants. Two secants, right? The secants cut through all the way. So two secants actually has a different formula than most. So let's take a look. I'm going to talk about my two arcs. So I'm going to start with this one, because I'm talking about the arcs that are inside my angle. Okay? So my angle is angle 1. So from here, I'm actually talking about just the ones that are on the inside. So that arc on the inside and this arc right here on the inside.
Does it matter which color? It doesn't.
No, it doesn't. It's just I need to have those two. Now, if you notice though, the color doesn't matter, but for this one right here, which one am I choosing for this one right here? Because there's a minus sign for this, and that minus sign plays a very important part. So which one has to go first?
Angle X.
Angle X, which is which one? It's a big one here on this in this case, right? So if I'm thinking about it right here, it's the furthest one minus the inside one. All right, so now let's take a look at this one over here. So I'm going to take a look at the next one. The next one, I'm going to label it. That one's going to be 2 tangents. So I have 2 tangents on this next one. And my other one right here. So again, this is a minus sign. And it's the outside, it's the further one. All right, so let's take a look. So this next one right here, this one right here is a secant and a tangent. So I have the big one, which is on the outside here. And I have this one here. Okay, basically the same formulas, right? If you're looking at them, the same formula, but the secants and tangents, they intersect at different places. So that's the only thing that's different. Okay? Now, let's take a look at my example now. My example is what type? Two secants? Class, you guys agree? Okay, so it's going to be a 2 secant. So now let's go ahead and color. So color my arcs. All right, so now let's go ahead and do this one. So from right here, it's going to be my formula, 1/2. So measure my angle, this one's X. 1/2, parentheses, what value goes first? 120 minus, very good. Now, from right here, just pick it up, put it in your handy dandy calculator if you need to. So it's basically going to be 80, half of 80. So measure angle X is 40 degrees. Is that pretty easy? Okay. Okay, so I'm going to break it up here for this example. Now, this example right here, what type of example is this? Say it, Matthew?
2 tangent.
2 tangent, very good. So, 2 tangents here. So with the 2 tangents, same formula, right? So measure angle X is, say, 1/2. What goes first? So let's go ahead and color it so we know. So what are we going to have?
240
240
minus 120.
minus 120. Okay, so this is going to give me 120, half of 120?
60.
60. So measure angle X is 60 degrees. Questions, concerns, complaints? How about secant tangent? It's the same type of problems. If you look at it, it's the same formula basically every single time. But a secant tangent, I would just use the different values. It's just the way it looks. That's all it is. It's the way it looks. That's going to be different.
Can we do an example?
I'm trying to look for the homework.
Because I need a visual example.
You need a visual example?
Yes.
Okay, so are you saying a visual example like number 10?
Exactly, like number 10.
Actually,
Number 6.
let's do 9. 9 would be a better. You said 6? No, because what type is 6?
Oh yeah, yeah.
6 is 2 secants, right?
Wait, is it number 9? Yeah.
Yeah.
Yeah, I was about to say, like,
Oh, here it is, here it is, here it is. Sorry, 5. 5 would be it.
That's the one we just.
okay.
No, because look, you asked for a secant tangent, right? Isn't 5 the secant tangent?
Yeah, that's what we said.
Okay, that's what I said. Booby traps. Anyway.
And that's what happened.
Okay. Did you color it yet? Color it. Color it. Color it.
I only have my shot.
All right. So, I colored it. I have a secant and a tangent. So, what is my thing gonna look like? I know you're not gluing that down, are you?
This is from 53, from 52.
So, measure angle A, B, C is equal to, what am I writing?
60. Oh, 210 minus.
Nope.
60.
1/2
Oh,
parentheses minus 62, right? It's that easy. And for number 10, 10's another one, but this time, here's your arcs. So your arc is here, your arc is here. This time you're trying to find the arc. So it gives you the angle, but you're trying to find the arc. So it's just like, kind of like what we did that last one, right? So to set this up, I would start off with my angle, which would be 56 equals, what am I writing? 1/2. 160 minus, is that MK? Yeah, arc MK. Okay, it's basically the same step, so this time you have a negative you have to deal with. Alright, get her done.